Alright, problem number 3. We have a plan view of a building, and shown here, and it says that all sides of the building meet at right angles, and we're given the length of 3 of the sides. Okay, so we're given this long side, and then this little short side is 2 meters. Okay, and they ask for the perimeter of the building. And at first glance, it just looks like there's not quite enough information. But if you look a little closer, you realize that it's not so bad. I guess my hint to you would be that you could probably draw a line here. Divide this. Should I put? I'll put a. No, I don't want that. I'll put a little dot here. Oh, it's gonna give me that again. Okay. so so if I divide this side, I could put a 2 down here. That might help you. Alright, so I'm going to go ahead and solve this. I guess the thing is that we have some vertical walls, or at least vertical according to my page here. I'm going to call this vertical and this horizontal. Okay. Of course, if it's a plan view, you're looking down from above. So this might be north, and this might be east. Okay. So we have some east and we have some west walls, and we have some north walls and some south walls. Okay. So these walls all face north, and these walls, this wall faces south, and this wall faces east, and then we have some westward facing walls. And if you look at it, you'll realize that the outside, the perimeter of this building completes a circuit. So if you were to trace around it, you end up back where you started from, right? So that means in order to end up where you started from, if you go south along this wall and you go west along this wall, in order to get back to where you started from, you've got to go north the same distance that you went south, and you have to go east the same distance that you went west. Okay, so if you look at this, this westward facing wall, and this westward facing wall, and this westward facing wall, and this westward facing wall all have to add up to 7, right? Because if we were to walk around the perimeter of this building, we could go 7 meters to the south, but in order to get back up to this corner again, we would have to go 7 meters north. Okay, so there you can see that the sum of all these walls has to be 7. So we know the eastward facing walls. We have an eastward facing wall of 7, and we have a bunch of westward facing walls that would be another 7. Okay. Alright, so now let's look at the north and south facing walls. We're given the south facing wall is 11, and we're given some north facing walls, and I'm going to mark these with a triple hash mark. Okay, so this northward facing wall, and this northward facing wall, and this portion of the northward facing wall here have to, if I draw a little dashed line here, you can see that all these northward facing walls have to add up to 11. Okay, so we have a southward facing wall, which is 11, and then we have the sum of all these northward facing walls, which is another 11. But here you can see we go east by 2 meters, and then we go north, and then we go west by 2 meters. So these two lengths here have to be the same, right? So we actually have 2 2-meter walls because of this concave section of the wall here. So So let's add 4 more meters. Okay, you see how I'm getting all that? So that takes care of all of our walls. We have 7, 11, we have the sum of the westward facing walls is another 7. We have these 3 northward facing walls that equal 11, and then we have this concave portion of the wall here, and it goes 2 in and 2 out, so we add 4 more. Okay, so let's add all that up. And what do we get? So it looks like we have 22, 26 plus 14 is 40. Okay, so, and that's in meters. So our perimeter is 40 meters.